Hello all, welcome to Sakti's AI Junction. In this video, I'll talk about self-attention in transformers. In my last video, I have given a fair idea about transformers in NLP and the overall architecture of it. So this self-attention is a very important concept in transformers. So we will see that in a detailed manner with one example. So why do we need self-attention? So when comparing with the traditional recurrent neural networks, this transformer model was able to capture the long-range dependencies and the relationships in the input sequence. Example, let's say like you have a large input sequence and the recurrent neural network will not be able to capture the what is the relationship between the first word and the last word. In this way, it is losing out the contextual meaning of it. Whereas in transformers, due to that self-attention mechanism, it will be able to identify the relationship between the first word and the last word in the same input sequence when the input sequence is very large. So in this way, the model will be able to understand the contextual meaning in a more robust and a flexible manner. So due to this self-attention, the transformers outperforms the sequential models in terms of accuracy and efficiency. So what is self-attention? It is a process of assigning weights or importance to different elements in the sequence based on their relationships or relevance to a particular element. So it computes attention weights. Each element, element in the sense like it's a word or a token, we can say it's a token. Yeah, each token computes its attention weight with respect to all other tokens in the input sequence. This attention weights will describe how much it is relevant to the when comparing with the other elements. For example, if you take a sentence, I love India, the word or the token I, it will compute an attention weight by comparing against the other two tokens, love and India. Similarly, the token love, it will compute one attention weight by comparing against the other two tokens, I and India. So the attention weight, it will give how much it has been related or how much it has been related to the other two tokens or in the same sequence. So on a high level, we will be going through these following terms: input embedding, key query and value vector, calculating attention base, attention distribution, weighted sum, and the final output. Input representation. Yes, each input sentence will be converted into a numerical representation vector called embeddings. This will capture the semantic meaning or contextual information of the words. Yeah, next comes the key, query, and value vectors. Okay, these vectors are the learned vectors which are derived from the input embeddings, and the self-attention mechanism it works on it works on the basis of key vector, query vector, and the value vector. So these vectors are calculated for each and every word. And like as I mentioned, if there is a sentence called I love India, then the key query value vector will be calculated for each and every token, calculating the attention weights. Yeah, so each token will be compared, will be compared against the other token. In the sense, the query vector of the current token will be compared against the key vector of all other tokens in the same sequence. Comparison in the sense, mathematically speaking, it's a dot product. So dot product of the query vector of the current element and the key vector of the all other elements will give similarity score after scaling. So this is the attention weight. Okay, so once we get that attention weight value, we have to pass it to the softmax function to normalize it. Softmax function, it is when you are giving an input vector to a softmax function, the output will be a probability distribution where all the weights will be added. The sum of the weights will be added to 1, and that is how a softmax function works. So the output of the softmax function, will always be, the weights will be always be equal to 1. The weighted sum. Okay, that till then, once we apply it to the softmax function, we will get the attention rate. The attention rate has to be multiplied against the value vector of the each word to compute the weighted sum. These value vectors gives the representation of the each word. Like for a given word, what would be its representation? That representation is obtained from the weighted sum. The weighted sum is nothing but when you are multiplying the attention weight against the value vector of the given word. Okay, the final output. The weighted sum, the final output is also called as a context vector, which gives the combined information of all the words in the sequence, given like giving more weight to the words that are most relevant to the word. So when you look at the weighted sum and the values which are closer to one, which means like they have more relevant to the current element that are being attended to. Let's see with an example. Let's say the given input sentence is I love the beautiful flowers. So when we tokenize it for a word tokenization, we will get all the individual words. Then the third one, we have to convert the words into embeddings. Embeddings is nothing but a vector representation. Ideally, we have to take embeddings for all the individual elements. But for our understanding, we are considering only the beautiful and the flowers. Okay. So the vector representation of beautiful is 0.2, 0.7, minus 0.3, and vector representation of flowers is minus 0.5, 0.4, 0.6. So just for our understanding purpose, this is a three-dimensional vector. Okay. From these each embeddings, we have to derive query vector, key vector, and a value vector for each individual elements. Hence said, for the word beautiful, we have three vectors, and for the flowers, we have three vectors. Okay. Now we will calculate attention weight. So now let's see like how do we calculate the attention weight for the word beautiful with respect to that of the word with respect to other word flower. So how it has been done is like, as I mentioned, like the query vector of the current word will be multiplied or a dot product against the key vector of the other word. So the query vector is 0.2, 0.7, minus 0.3, and it has been a dot product with the key vector of the word flower minus 0.5, 0.4, and 0.6. And the output will be sent to a softmax function, so that the weighted sum will be equal to, it will be lesser than 1. Okay, so like we would be doing this for all the words against other words. Like I, we have to calculate for I against love the beautiful flowers. Same way we have to calculate for the word love by comparing against I the beautiful flowers. For our understanding, I have just taken only the combination of beautiful and the flowers. Now the weighted sum. Now assume the attention weight from the fifth step is 0.8. Okay. Now what we have to do, this 0.8 has to be multiplied against the value vector of the words beautiful and the flowers. Now the weighted sum will be calculated as attention weight into value vector. Okay. Now once we multiply, we will get a final vector in this format 0.6, 0.56 minus 0.24. So this attention, what is that? This context vector will gives the complete contextual meaning of the word beautiful in this entire sequence. Same way, this context vector of the word flower that will give it a contextual meaning or it's a representation in this entire sequence. This is how we calculate attention weight and the weighted sum. So by looking at that, attention weights, we would be able to tell what is the relationship between that pair of words. In this example, I just mentioned, assume the attention weight is 0.8 between the beautiful and flowers, which means there's a more contextual meaning between the words beautiful and the flowers. If the attention weight is less, it's let's say if the attention weight 0.1 or zero point 0.2 between the words, then which means the two words are not contextually or not contextually related or not more important. We'll take another example. Let's say like the cat sat on the mat. Okay, and if I calculate attention weight for the word sat, it might probably give more weightage uh, to the word mat. So in that case, the attention weight will be close to 0.8 or 0.9. In this way, the model will be able to identify the relationship or the relationship between the words in case of even though when the context is very large. So this is how the attention weight or the self attention works. Thank you. Please like and subscribe to Sakhi's AI Junction.